Of is magnetic field due to a current carrying state conductor. We have already discussed in the all-state activity that whenever we pass electric current through a conducting wire, then a magnetic field is developed around it, which we can detect with the help of deflection in the magnetic compass if we place nearby the wire when the current is drawn in it. Now, there exists a magnetic field around a state conductor which carry current and it is in the form of concentric circular field line with the conductor at the center. Means what kind of nature of magnetic field around a state conductor which carry current? Actually, the magnetic field line arranged in the shape of a concentric circles in which the wire is at the, or means we can say conductor is at the center of this field. As we go away from this wire, the circle becomes larger and larger. Now the next is direction of magnetic field line. This direction of magnetic field line around a state conductor can be found with the help of right hand thumb rule. According to right hand thumb rule, imagine that a state conductor is in your right hand in such a way that the thumb will point out the direction of current, then the direction of curling the finger gives the direction of magnetic field line. Just see in this activity, since the current is passed in the wire from X to Y, because the polarity of battery plus sign is above, that is why the current goes from positive sign towards the negative signs, means in the conductor X to Y it passes from north to south. So we have to keep the thumb in the downward direction. Now these fingers, the curling of finger will show the direction of magnetic field line. Means here with the help of compass, if we trace the magnetic field line around this conductor, then the compass needle will point out the direction in the anti-clockwise. As we take the compass needle away from this conductor, then it will direct us to go in the circle which are in the clockwise direction. So these all are the direction of magnetic field around a state conductor. Now the magnetic field, magnitude of magnetic field whose symbol is B, means how much is the strength of magnetic field around the state conductor. It depends on the two things. First of all, when we increase the current, the magnetic field line will increase. This can be arranged with the help of a rheostat. If we move the knob of rheostat, the current will increase, and when the current will increase, more and more circle will be formed. It means the strength of magnetic field, or we can say magnitude of magnetic field, which is B, is directly proportional to the amount of current which flow in the conductor. Means B proportional to I. Another, B is inversely proportional to the distance of the point from the conductor. Means B is inversely proportional to R, where R is the distance. By combining both the factor 1 and 2, we can get an expression B proportional to I by R. Now unit of B means magnetic field line. Magnitude of magnetic field line can be expressed in the form of Tesla. The unit is Tesla. Now we shall study magnetic field due to a current carrying coil. We can take an activity. In a cardboard, there is a circular coil which is inserted inside it. Half portion is above, half portion is below. And when we pass current with the help of a battery whose positive terminal is in this side and negative terminal is in this side, a key is also connected. In this way, when this circular coil carry current, then some magnetic field is developed around the ends of the coil, which we can be find with the help of iron filing. If we spray iron filing on the cardboard and tap it by our hand, then this kind of pattern will be arranged. One of the way is this. The another way to trace the magnetic field line around the circular coil, we can use the magnetic compass. If we keep the magnetic compass at this place, then the compass will point out the direction towards the clockwise. Means as we move towards the pointer, then it will form a complete circle. So the circular lines, concentric circular lines are formed nearby the state conductor, nearby the one end of the coil. In the another end also the concentric circles are formed, but the direction of magnetic field line can be found with the help of right hand thumb rule. So the magnetic field line near the coil are nearly circular and concentric. Its direction can be found by the help of right hand thumb rule, because in the state conductor we find the direction of magnetic field line by the right hand thumb rule. Near the center of the coil, the field line become parallel and straight. You can see as we go away from the coil, the circle become larger and larger. As we reach at the center, the magnetic field line become nearly straight and parallel. In this way, we can say that magnetic field at the center of the circular coil is uniform in nature. Now the third point is the direction of magnetic field is perpendicular to the direction of the plane of the coil. The plane of the coil is horizontal, whereas the plane of the coil is vertical, whereas the magnetic field line form on the horizontal plane. Direction of magnetic field by the clock rule also we can find. Looking at the face of a coil, if the current around that face is clockwise, if we look around the face of any coil and the direction of current is suppose clockwise direction, then this face will be point out the south pole. If the current around the face is anti-clockwise direction, then the face is behave like a north pole. You can see in this loop the direction of current is clockwise, that is why it appears it behave like a south pole. In the coil from a face, if the direction of current is anti-clockwise, then that face will behave like a north pole. Now we shall discuss magnitude B of magnetic field produced in a circular loop of current carrying. Instead of a single circular loop, this time we have taken a coil in the shape of a circle. Means many wires are there, many loops are there which are inserted in the cardboard and connected with the help of electric source of electric current. Now when the electric current flow through this loop, then again magnetic field is developed, but this time the strength of magnetic field is larger. First of all, B proportional to I, because the current in each loop move in the same direction, that is why the amount of current will be added up, and that is why the magnitude of field will increase as the current increase. So B proportional to I. Another is B proportional to 1 by R. As the distance from the circular coil increase, then the B means magnetic field will decrease. The third point, B proportional to N, where N is the number of turns, means more will be the number of turns in this coil, the more will be the magnitude of magnetic field. So if a circular coil having N turns, the field produced in the is N time as large as that produced in a single turn, because the current in each circular turn has the same direction. That is why the field due to each turn will be added up and it produce a larger field around the coil. So we can conclude that the magnetic field, strength of magnetic field will be increased by increasing the number of turns. Even the by the help of direction of coil, direction of current inside the coil, we can find the poles, or we can say polarity of the magnetic field produced. If the direction of current is in the clockwise direction, then that face will look like behave like a south pole, and in towards a face in which the direction of electric current is anti-clockwise direction, so that face will behave like a north pole. So in this circular loop we can find the polarity of magnetism also, north pole, south pole. As we go inside center of the loop, then the strength of magnetic field will be stronger, means largest at the center. So as we go away from the loop, means middle of the loop, it will increase and it become largest in the center, because half the portion of the coil means suppose this is the A end, this is the B end. Due to A end and B end, the magnetic field, strength of magnetic field will be add up at the center, and that is why it will largest in the center. Now we shall discuss magnetic field due to a current carrying solenoid. First of all, what is solenoid? If we turn a conducting copper wire around a cylindrical hollow tube in such a way that its length is more than its diameter, then this kind of hollow coil is known as solenoid. So if a solenoid is attached with the help of a battery key, then the current will flow in the solenoid, and a current carrying solenoid also develop a magnetic field around it. So the characteristic of magnetic field is the magnetic field line inside the solenoid is straight, so field is uniform. You can see inside the solenoid the magnetic field line are nearby, straight and parallel to each other. That is why a uniform magnetic field is produced inside the solenoid. But when we look around it, then the pattern is same like a bar magnet. Means the solenoid act like a bar magnet in which the magnetic field line always emerge from the north pole and merge in the south pole. The second point, the field line emerge from the north pole and merge in the south pole. Exactly same pattern as a bar magnet. So around a solenoid, the magnetic field is exactly same as bar magnet. The direction of magnetic field line, the end of the solenoid at which the current flow in anti-clockwise direction. If we look from this end, the current is flowing in the anti-clockwise direction, then this end will act like a north pole, while the end at which the current flow in clockwise direction behave like a south pole. Again, the last, magnitude of magnetic field. Whatever magnetic field is developed around a solenoid, its magnitude can be vary. First of all, it depends on the amount of electric current. As we increase the current, the strength of magnetic field will increase. Another, by increasing the number of turns in this solenoid. More is the number of turns, more stronger magnetic field is developed around the solenoid. Magnetic field produced by a solenoid can be used to magnetize a magnetic material. So if we place a core material inside this solenoid and then we pass the current in it, then this core material, means soft iron, get magnetized, and this kind of magnet is also called electromagnet. So a powerful electromagnet can be prepared by placing a soft iron magnetic material as a core material inside the solenoid. Then it will produce a very strong magnetism, and this is called electromagnet.